Hello there and welcome. I'm delighted you've joined me for this gentle journey into one of the most mind-bending questions science has ever dared to ask. Does the future already exist? Are your plans for next week, your retirement dreams, even the words you'll speak tomorrow morning, already written somewhere in the fabric of reality, just waiting for you to catch up? It's a question that sounds almost absurd at first hearing, like asking whether purple tastes louder than Tuesday. But stick with me, because this isn't just philosophical wordplay. This is a genuine scientific puzzle that sits at the intersection of physics, consciousness, and the very nature of existence itself. Before we drift into this temporal puzzle together, I'd love to know where in the world you're listening from tonight, and what tomorrow looks like from where you sit. Perhaps you're facing Monday morning with its familiar mixture of dread and possibility, or maybe it's already Tuesday where you are, your tomorrow having transformed into today while others still sleep. Isn't it curious how we're all scattered across different moments as we ponder the nature of future moments themselves? Time zones are funny things. They remind us that what counts as now, as today, as the present moment, is surprisingly arbitrary. Your midnight is someone else's noon. Your tomorrow is someone else's yesterday. And yet we all feel like we're moving forward through time together, even when our clocks disagree about what time it actually is. Now, I do hope this isn't so intriguing that it keeps you awake, but if it does, well, at least you'll drift off pondering one of the deepest mysteries of existence, which is arguably a better use of insomnia than worrying about whether you remember to lock the door or turn off the stove. There's something almost meditative about contemplating these vast questions. They put our daily concerns into perspective, reminding us that we're part of something much larger and stranger than our ordinary experience suggests. So settle in. Let your thoughts slow to match the gentle rhythm of this exploration. And let's begin our journey into tomorrow's mysteries. Because somewhere between what is and what will be, between the certainty of now and the uncertainty of next, lies a question that could change everything you think you know about time, choice, and the nature of reality itself. We'll travel from the common sense world where tomorrow doesn't exist yet, through Einstein's revolutionary insights about the nature of space-time, into the quantum realm where possibilities dance in superposition, and perhaps even peek into the philosophical implications of living in a universe where your future might already be as real as your past. This isn't just an academic exercise or a thought experiment designed to impress dinner party guests. The question of whether the future exists touches on some of the most practical aspects of human life. How we answer it influences how we think about planning, about hope, about regret, about the meaning of choice itself. If your future already exists, fixed and immutable in the block of space-time, what does that mean for your sense of agency? If it doesn't exist, if it's truly open and undetermined, what does that mean for your sense of security and continuity? We'll explore these questions gently, without rushing toward easy answers, because like time itself, they deserve to be savored, contemplated, allowed to settle into the quiet spaces of the mind where wonder lives. Whether you're a night owl encountering these ideas in the small hours, or an early bird winding down after a long day, you're part of this temporal mystery. Your consciousness, your ability to remember the past and anticipate the future, your sense of moving through time from moment to moment, these are the very phenomena that make the question of future existence so puzzling and so profound. The universe keeps its temporal secrets well, but tonight we'll see what clues we can gather from physics, philosophy, and the strange experience of being conscious creatures embedded in time's flow. Let's start with what feels obvious, what every fiber of your being tells you about the nature of tomorrow. The future doesn't exist yet. Right now, as you listen to these words, as your lungs draw breath and your heart beats its steady rhythm, tomorrow is a blank page waiting to be written. Your future decisions haven't been made, your future conversations haven't been spoken, and your future self is still being shaped by choices you haven't even considered. This view, which philosophers call presentism, suggests that only the present moment is real, genuinely, concretely real, in the way that your current thoughts are real, in the way that the sensation of breathing is real, in the way that the sound of these words reaching your ears right now is undeniably, immediately real. The past, in this view, is gone, filed away in memory and history books, preserved in photographs and scars, in tree rings and fossil layers, but no longer existing in any concrete sense. Yesterday's breakfast was real when you ate it, but now it's just a memory, a pattern of neural connections in your brain, a story you tell yourself about what happened. The future is even less substantial, nothing more than possibility, a collection of maybes floating in potential like seeds, waiting for the right conditions to sprout into actuality. This seems perfectly reasonable, doesn't it? It matches how we live our daily lives with remarkable precision. We plan for tomorrow precisely because we believe we can influence it, because we understand that the future is genuinely open to our input. We worry about next week because we think our actions today matter for what comes next. We save money for retirement because we believe there will be a future self to benefit from our present sacrifice. We make appointments because we assume there's a real tomorrow waiting to receive these commitments from our current selves. We promise to call our friends, to exercise more, to finally organize that cluttered closet, all because we operate under the assumption that the future is malleable, responsive to our intentions and efforts. This presentist view gives weight to our choices. When you decide what to have for breakfast tomorrow, that choice matters because it will bring a particular future into existence. When you choose to be kind or cruel, to work hard or coast along, to reach out to an old friend or let relationships fade, these decisions matter because they sculpt the shape of what's to come. The future, in this understanding, is democracy in action. Every choice is a vote for the kind of tomorrow you want to inhabit. The presentist universe is also morally clear. Responsibility makes sense because the consequences of our actions haven't happened yet. We can still change course, still make different choices, still become different people. If you've made mistakes, they're in the past, finished and unchangeable. But your future remains yours to shape. This gives hope real meaning and regret real sting, because both acknowledge the fundamental difference between what was and what could be. Consider how this view aligns with our deepest intuitions about time. You can't visit next Tuesday the way you might visit Paris. You can't touch or observe future events, can't take photographs of tomorrow or bring back souvenirs from next month. They haven't happened yet, so in what meaningful sense could they be said to exist? When you imagine your future self, you're not remembering something real. You're constructing possibilities, painting with the colors of hope and expectation on the canvas of time that hasn't yet been stretched. This presentist understanding also explains why prediction is so difficult. If the future doesn't exist yet, then even perfect knowledge of present conditions can only give us probabilities, educated guesses about what might unfold. Weather forecasts become less accurate the further ahead they reach because they're not reading an already existing future. They're extrapolating from current conditions into genuine uncertainty. Stock markets fluctuate because they're pricing possibilities, not actualities. Sports remain exciting because the outcome hasn't been written yet, somewhere in the cosmic script of predetermined events. The presentist view treats time as fundamentally creative. Each moment brings something genuinely new into existence. Right now, as you breathe and think and exist, you're participating in the creation of reality itself. The universe is an unfinished story, and consciousness, choice, and chance are its co-authors. This moment has never existed before and will never exist again. When it passes, it will join the vast archive of the past. But right now, it's the cutting edge of existence, the place where being unfolds into becoming. But here's where things start to get interesting, where the comfortable certainty of presentism begins to crack under the pressure of modern physics. What if this perfectly reasonable, everyday understanding of time, this intuitive sense that only now is real, is completely wrong? What if the feeling that the future doesn't exist yet is just that, a feeling, a quirk of consciousness rather than a truth about reality? What if tomorrow is already out there, somewhere in the landscape of space-time, as real as yesterday, as concrete as this very moment, just waiting for your awareness to catch up to it? The implications would be staggering, reshaping everything from free will to the meaning of death, from the nature of hope to the reality of change itself. In 1905, a young patent clerk named Albert Einstein published a theory that would shatter our common-sense understanding of time forever. Special relativity didn't just change physics. It changed the very nature of existence itself, turning our intuitive understanding of past, present, and future into something far stranger and more wonderful than anyone had imagined. According to Einstein, space and time aren't separate entities floating independently in some cosmic void. Instead, they form a single unified fabric called space-time, woven together so intimately that you can't have one without the other. And in this four-dimensional block universe, something extraordinary happens. All moments in time, past, present, and future, exist equally and simultaneously. Imagine the universe as a vast loaf of bread, freshly baked by cosmic forces we're only beginning to understand. Each slice represents a moment in time, but here's the crucial insight. The entire loaf exists all at once. Your childhood birthday parties, this very instant as you listen to these words, your eventual future self-reading bedtime stories to grandchildren not yet born, they're all just different slices in the same cosmic loaf. You're not moving through time so much as existing across it, like a thread woven through the entire fabric, experiencing different parts of your existence as your consciousness encounters each temporal slice. This view, called eternalism, or the block theory of time, suggests something that would have horrified our ancestors and continues to puzzle philosophers today. When you worry about tomorrow's presentation, that presentation already exists. When you wonder what you'll be doing in 10 years, you're already doing it, somewhere else in the block. The future isn't approaching you like a train coming down the tracks. You're simply becoming aware of slices of space-time that were always there, waiting for your consciousness to discover them. But why should we believe such a strange idea? After all, it contradicts everything our senses tell us about the nature of time. We feel time flowing. We experience the present as somehow special, more real than memory or anticipation. We make choices that seem to create the future rather than reveal it. What could possibly convince us to abandon this deeply felt understanding of temporal reality? The answer lies in Einstein's most profound insight. The speed of light is constant for all observers, regardless of how fast they're moving. This seemingly simple fact has consequences that ripple through our understanding of everything. In the old Newtonian universe, if you were traveling toward a source of light, you'd expect to measure that light as moving faster, just as raindrops seem to fall harder when you're driving through a storm. But experiments consistently showed that light always travels at the same speed, roughly 300 million meters per second, no matter how fast you're moving toward or away from it. This cosmic speed limit isn't just a traffic law for photons. It's a fundamental feature of space-time itself, woven into the very structure of reality. To preserve this constant speed of light, Einstein realized that space and time must be flexible, able to stretch and contract to keep light's speed fixed. If you're moving very fast, distances contract and time dilates. Your measuring stick shrinks and your clock slows down, but you don't notice, because everything in your reference frame, including your brain and body, changes together. To you, everything seems normal. It's only when you compare notes with someone moving at a different speed that the strangeness reveals itself. This leads to one of the most mind-bending consequences of special relativity: time dilation. The faster you move, the slower time passes for you relative to someone standing still. If you were to board a spaceship and zoom around the galaxy at 90% the speed of light, something remarkable would happen. Years could pass on Earth while you experienced only months. You'd age more slowly, think more slowly, even digest your space food more slowly, though you wouldn't notice any of this because your subjective experience would feel perfectly normal. This isn't science fiction speculation. It's been measured and confirmed countless times. Particles accelerated to high speeds in laboratory experiments live longer than they should according to their natural decay rates. Atomic clocks flown on airplanes tick slightly slower than identical clocks left on the ground. GPS satellites orbiting Earth must constantly adjust their clocks to account for both their high speed and their distance from Earth's gravitational field. Without these relativistic corrections, your phone's map would be off by several kilometers within hours. But the implications go far deeper than practical technology. If time passes differently for different observers, if your now can be different from someone else's now, then what does that say about the nature of existence itself? It suggests that there's no universal present moment, no cosmic clock ticking away the seconds for everyone simultaneously. Instead, the present moment is personal, relative, dependent on your motion through space-time. This insight led Einstein and others to embrace the block universe model. If there's no universal now, if simultaneity is relative, then perhaps all moments in time are equally real. The past doesn't become less real just because you're no longer experiencing it. The future doesn't become more real when you finally encounter it. They're all just different regions of the four-dimensional block, each as solid and concrete as any other. Think of it like exploring a vast building. When you leave one room and enter another, the first room doesn't cease to exist. It's still there, still real, even though you're no longer experiencing it. In the same way, when you move from today to tomorrow, today doesn't vanish into unreality. It remains part of the permanent structure of space-time, as real as it ever was, just no longer accessible to your current slice of consciousness. This view transforms our understanding of existence itself. You're not a fleeting spark of consciousness struggling against the passage of time. You're a permanent feature of the universe, a four-dimensional object extended through space-time from birth to death. Every moment of your life, every thought you've ever had or will have, every choice you've made or will make, they're all equally real, different cross-sections of your extended existence through the temporal dimension. Einstein himself found this view both beautiful and unsettling. When his lifelong friend Michel Besso died, Einstein wrote to comfort Besso's family. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. If the block universe is true, then death itself might be an illusion, a perspective effect that occurs when consciousness can no longer access future slices of space-time. Your future self, in this view, is as real as your current self, just located elsewhere in the four-dimensional landscape of existence. But the strangeness of Einstein's revelation runs even deeper than we've yet explored. The relativity of simultaneity doesn't just suggest that the future might exist. It provides compelling evidence that it must exist, at least if we want to maintain any coherent notion of objective reality. Let me walk you through one of the most unsettling implications of special relativity, something that will either fascinate you into peaceful contemplation or keep you awake wondering about the nature of existence itself. Imagine two observers, Alice and Bob, a classic pairing in physics thought experiments, though perhaps not the most creative names. Alice is sitting comfortably on Earth, perhaps in a chair much like yours, while Bob is traveling through space in a rocket ship at tremendous speed, say 80% of the speed of light. Now, according to special relativity, Alice and Bob will disagree about what events are happening now throughout the universe. Their relative motion creates different slices through spacetime, different definitions of simultaneity that are equally valid from the perspective of physics. Here's where it gets interesting. When Alice looks at her watch and declares, "Now," pointing to this very moment as the present, Bob, because of his high-speed motion, would disagree. His now includes events that Alice considers to be in the future. Not the distant future, perhaps, but definitely events that haven't happened yet from Alice's perspective. Bob's present moment, his slice of now through spacetime, cuts through Alice's tomorrow. This isn't just a measurement problem or a quirk of synchronized clocks running at different rates. The fabric of spacetime itself is structured so that there's no absolute, universal present moment. If you could somehow take a snapshot of everything happening now in the universe, someone moving at a different speed would take a completely different snapshot and be equally correct. Your now and their now would be different slices through the same four-dimensional reality. But here's the crucial point. Bob can observe these future events right now in his present moment. From his perspective, things that Alice considers future are happening simultaneously with things Alice considers present. If Bob has a powerful telescope and looks toward Earth's general region of space, he could, in principle, observe events in Alice's future. Not because he's seeing the future, but because those events are part of his present. This creates a logical puzzle that's hard to escape. If Bob can observe Alice's future events as part of his present reality, in what sense are those events unreal or non-existent? How can something be real enough for Bob to observe but unreal from Alice's perspective? Reality doesn't usually work that way. Things either exist or they don't. The universe doesn't maintain separate versions of reality for different observers. The relativity of simultaneity forces us toward an uncomfortable conclusion. If future events are real for some observers, they must be real absolutely. The future can't be real for Bob but unreal for Alice. That would require reality itself to be inconsistent, to contradict itself depending on who's looking. Physics doesn't allow for such arbitrary distinctions. This means that right now, as you listen to these words, events that you consider to be in your future are happening somewhere in space-time. Tomorrow's sunrise, next week's conversations, next year's surprises, they're all unfolding in the present moments of observers moving at different speeds relative to you. From their perspective, your future is as concrete and immediate as your current experience. The implications ripple outward in ways that can be both comforting and disturbing. If your future already exists, then in some profound sense you're eternal. Every moment of your life, past and future, has equal claim to reality. Your childhood wonder, your current thoughts, your eventual wisdom, they're all equally real, different chapters in the four-dimensional story of your existence. Death becomes not an ending but a boundary, like the edge of a photograph. The photo doesn't cease to exist when you stop looking at it. But this view also challenges our sense of agency and choice. If your future self is already out there in space-time, living a life that's as real as your current one, making decisions that are as concrete as the one you made for breakfast this morning, then what does that say about free will? Are your future choices already made? When you agonize over important decisions, are you discovering something that already exists rather than creating something new? Some philosophers argue that the block universe actually preserves free will rather than eliminates it. Your future choices might be real, but they're still your choices. The future version of you who decides to learn a new language or move to a different city or call an old friend, that's still you making those decisions. The choice isn't less real because it exists in space-time. If anything, it might be more real, permanently embedded in the structure of the universe rather than fleeting and temporary. Others find this view disturbing, arguing that genuine choice requires an open future, real alternatives that could have gone differently. If your future is already laid out in space-time, they argue, then your sense of deliberation and decision-making is illusory. You're not choosing, you're just discovering choices that were always there. But perhaps this debate reveals something about our assumptions rather than the nature of time. We tend to think that for something to be real, it must be changeable, malleable, responsive to our will. But consider the past. Your childhood experiences are fixed, unchangeable, beyond your ability to modify. Yet we don't usually conclude that the past is unreal, or that your past choices weren't genuine choices. They were your choices, made by your past self, with real deliberation and consequence. Perhaps future choices work the same way. Real, genuine, yours, but viewed from the perspective of space-time rather than the flowing river of subjective experience. The block universe doesn't eliminate the importance of choice, it relocates it. Instead of choices creating the future, choices might determine which future exists in your personal thread through space-time. Your decisions don't bring tomorrow into existence, but they determine what kind of tomorrow you encounter as your consciousness moves along its world line through the four-dimensional block. If the block universe is true, if your entire life, from birth to death, already exists somewhere in the four-dimensional landscape of space-time, what does that mean for how we experience our daily lives? Are we like passengers on a train, watching the scenery of time scroll past our windows, believing we're moving forward when really we're just becoming aware of landscapes that were always there, fixed and immutable in the geography of existence? This question touches something deep in human experience, something that goes to the heart of what it means to be conscious, to make choices, to hope and fear and dream about what's to come. Some philosophers suggest that our sense of time's passage is indeed an illusion, though perhaps illusion is too harsh a word. It's more like a perspective effect, the way a three-dimensional sculpture appears different depending on which angle you view it from. We don't move through time. Our awareness slides along our world line, the path we trace through space-time, creating the feeling of temporal flow. Think of it like reading a book. The entire story exists all at once. Every chapter, every page, every word already written and fixed. But your experience of the story unfolds sequentially as your attention moves from word to word, page to page. The story doesn't change, but your awareness of it creates the experience of narrative flow, of events unfolding, of surprises and revelations emerging from what was always there. In this view, your consciousness is like a spotlight moving along the thread of your existence through space-time. At any given moment, the spotlight illuminates a particular slice of your life, creating the vivid sense of now. The past feels different from the future, not because one exists and the other doesn't, but because of the direction in which your consciousness moves along your world line. You remember the past because those experiences have already been illuminated by the spotlight of awareness. You don't remember the future because your consciousness hasn't reached those slices of your existence yet. This raises profound questions about free will and choice that have kept philosophers awake for centuries, though perhaps not as peacefully as we might hope. If your future already exists somewhere in the block, laid out like a map of your entire life, are your decisions real? When you choose chocolate over vanilla tomorrow, is that choice already made, already existing in the future slice of space-time that contains tomorrow's ice cream shop? When you decide to call an old friend, to change careers, to move to a new city, are these genuine choices, or simply the discovery of decisions that were always part of your world line? Yet here's something to consider that might ease these concerns. Even if the future exists, it doesn't necessarily mean it's fixed or determined by forces outside your control. The block universe tells us about the structure of time, but it doesn't dictate the content. Your future self might already exist, but that existence could still be the product of the genuine choices you make as your consciousness encounters each moment. The decisions feel real because they are real. They're your decisions, made by you, shaping the contours of your path through space-time. Consider an analogy that might help. Imagine a river flowing through a landscape. The river's path from source to sea already exists, carved into the geography of the land. But the water flowing through that riverbed is still genuinely moving, still making a real journey from beginning to end. The pre-existence of the riverbed doesn't make the water's journey less real or meaningful. In the same way, your consciousness might be flowing through a pre-existing structure in space-time, but the flow itself, the experience of moving from moment to moment, remains genuine and significant. The block universe might also change how we think about identity and continuity. If all moments of your existence are equally real, then you're not just the person you are right now in this present instant. You're the entire four-dimensional being that extends from your birth to your death, encompassing every age, every stage of growth and change, every moment of joy and sorrow. Your 5-year-old self isn't gone. That self exists permanently in the early sections of your world line. Your future elderly self isn't waiting to come into existence. That self already exists in the later sections, living a life that your current consciousness hasn't yet discovered. This view can be oddly comforting. It suggests a kind of immortality, not in the sense of consciousness continuing after death, but in the sense that every moment of your life has permanent reality. Your first laugh, your graduation day, quiet evenings like this one listening to ideas about time and existence, they don't fade into nothingness when they pass. They remain forever real, forever part of the block, different chapters in the enduring story of your existence through space-time. Some find this perspective liberating. It can ease the pressure of trying to hold on to fleeting moments, the anxiety about time slipping away, the fear that experiences will be lost forever. If every moment has permanent reality, then nothing is truly lost. Your happiest memories aren't fading echoes, but permanent features of reality, as solid and enduring as mountains, just located elsewhere in the four-dimensional landscape of space-time. Others find it troubling, even claustrophobic. If your entire life already exists, if every mistake and triumph is already laid out in the block, does that leave room for growth, for change, for the feeling that tomorrow could be genuinely different from today? But perhaps this worry stems from thinking about the block universe in two deterministic terms. The block tells us that all moments exist, but it doesn't necessarily tell us why they exist the way they do, or prevent them from being the result of genuine choice, chance, and the complex interplay of consciousness with reality. But let's complicate our picture of predetermined futures with quantum mechanics. That delightfully strange realm where particles waltz in superposition and reality refuses to commit to definite outcomes until someone bothers to look. Quantum theory suggests that the future isn't just unknown to us. It's genuinely undetermined until the moment quantum measurements collapse, clouds of possibility into concrete reality. This creates a fascinating tension with Einstein's block universe, one that scientists and philosophers continue to wrestle with in ways that would make a cosmic wrestling match look straightforward. Consider the phenomenon of radioactive decay, quantum mechanics' favorite example of pure randomness. Take a single uranium atom sitting quietly in a laboratory. When will it decay, releasing its energy and transforming into a different element? According to quantum mechanics, this question has no answer, not because we lack sufficient information or measuring tools, but because the moment of decay is fundamentally random. There's no hidden clock inside the atom, counting down to a predetermined moment. There's no secret variable determining when the decay will occur. The timing is genuinely, irreducibly uncertain until it happens. If quantum mechanics is correct about this randomness, and most physicists believe it is, then the future cannot be completely determined by present conditions. Tomorrow's quantum events haven't been decided yet because there's nothing to decide them. They exist in what physicists call superposition, a ghostly combination of all possible outcomes that doesn't collapse into definite reality until measurement forces the quantum system to choose. This quantum indeterminacy permeates everything at the microscopic scale. Every chemical reaction, every neural firing in your brain, every photon absorption in your retina involves quantum processes that are fundamentally probabilistic. The exact moment a photon hits your eye, triggering a cascade of neural activity that might lead to a particular thought or memory or decision, that moment is governed by quantum uncertainty. Your thoughts themselves might be influenced by quantum randomness bubbling up from the microscopic realm into the world of consciousness and choice. This creates a profound puzzle when we try to reconcile quantum mechanics with the block universe. If the future already exists, containing definite outcomes for every quantum event, then quantum mechanics might be incomplete. Perhaps there are hidden variables, deeper layers of reality that determine outcomes in ways we haven't yet discovered. This was Einstein's hope. He famously declared that God does not play dice with the universe, expressing his belief that quantum randomness must be an illusion hiding deeper deterministic mechanisms. But experimental tests of quantum mechanics, particularly violations of Bell's inequality, suggest that Einstein was wrong about this. Quantum randomness appears to be genuine, not just a reflection of our ignorance. The universe does seem to play dice, and those dice rolls aren't predetermined. This leaves us with several possible ways to understand the relationship between quantum uncertainty and temporal existence. One possibility is that the block universe is real, but it's not a single, definite block. Instead, it might be a superposition of all possible blocks, a quantum multiverse where every possible future exists simultaneously. In this view, your future doesn't just exist. All possible futures exist, branching and diverging with every quantum event. The uranium atom both decays and doesn't decay, creating parallel timelines where both outcomes are real. Your future self both chooses chocolate and vanilla, both calls that old friend and lets the phone ring unanswered, both takes the job offer and turns it down. This many worlds interpretation preserves both the reality of the future and the genuineness of quantum uncertainty. The future exists, but it's not singular. It's a vast branching structure of possibilities, all equally real, all playing out simultaneously in different branches of the quantum multiverse. When you make a decision, you're not creating the future. You're determining which branch of an already existing future you'll experience. Another approach suggests that the block universe might be real but incomplete. Perhaps only the past is fixed and definite, carved in stone by the irreversible march of entropy and measurement. The present might be the growing edge of reality, the place where quantum possibilities crystallize into definite outcomes. The future would then exist as potential, as information encoded in quantum fields and probability waves, but not yet as concrete reality. This growing block theory attempts to preserve both the insights of relativity and the implications of quantum mechanics. It acknowledges that simultaneity is relative while maintaining that there's something objectively special about the present moment, the boundary between determined past and undetermined future. In this view, the future exists as possibility space, real in the sense that mathematical possibilities are real, but not yet actualized into the concrete existence we associate with past events. The relationship between consciousness and quantum measurement adds another layer of mystery. Some interpretations of quantum mechanics suggest that consciousness plays a special role in collapsing quantum superpositions, in choosing which possibility becomes reality. If this is true, then conscious observers might be participants in creating the future rather than passive discoverers of what already exists. Your awareness, your choices, your observations might be helping to weave the fabric of reality itself, determining which threads from the loom of possibility become the solid cloth of space-time. But even without invoking consciousness directly, quantum mechanics suggests that the future might be more fluid than Einstein's block universe implies. Instead of a fixed four-dimensional structure, reality might be more like a growing crystal, with new layers of definite existence being added moment by moment as quantum uncertainties resolve themselves into concrete outcomes. The future would exist as the natural evolution of present quantum states, real as potential but not yet real as actuality. This quantum perspective offers a middle path between the rigid determinism of a fully existing future and the complete openness of presentism. It suggests that tomorrow is neither completely real nor completely unreal, but something more subtle, a collection of probabilities weighted by the quantum amplitudes of present states, a garden of possibilities, waiting for the quantum gardener of measurement and observation to cultivate specific outcomes into full reality. One way to reconcile the apparent contradiction between Einstein's eternal block and quantum uncertainty is through the many worlds interpretation of quantum mechanics, a theory so ambitious. It doesn't just propose multiple futures, but infinite realities, each as concrete and real as the one you're experiencing right now. In this view, every quantum event, every moment when the universe faces a choice between possible outcomes, doesn't just select one option. Instead, reality splits, branching into multiple parallel worlds where every possibility plays out simultaneously. Consider that uranium atom we discussed, sitting in its laboratory, poised on the quantum knife edge between decay and stability. In the many worlds interpretation, when the moment of potential decay arrives, the universe doesn't flip a cosmic coin to choose decay or no decay. Instead, it branches into two equally real realities. One where the atom decays, releasing its energy in a tiny flash of transformation, and another where it remains stable, continuing its patient existence for another moment, another hour, another century. But here's where things become truly staggering in their implications. Every quantum event in the universe is doing this, constantly, billions upon billions of times per second. Every photon that might or might not be absorbed, every electron that could tunnel through a barrier or bounce off it, every chemical reaction that proceeds by quantum rules, all of them are splitting reality into parallel branches. The result is an ever-expanding tree of universes, a quantum multiverse of unimaginable scope and complexity. In this picture, the future doesn't just exist. All possible futures exist. There's a branch of reality where you chose tea instead of coffee this morning, where you took a different route to work, where you said yes instead of no to that invitation you declined. There's a world where you became a musician instead of whatever path you actually chose, where you moved to that city you always wondered about, where you called that person you've been meaning to contact for years. Every choice you didn't make, every word you didn't speak, every path you didn't take, they're all being lived out by other versions of you in parallel realities. This might sound like science fiction, but Many Worlds is a serious interpretation of quantum mechanics, developed by physicist Hugh Everett in 1957 and supported by notable scientists including David Deutsch, Max Tegmark, and Sean Carroll. It solves several puzzles in quantum theory by taking the mathematics literally. Instead of wondering why quantum superpositions collapse into definite outcomes, Many Worlds suggests they don't collapse at all. All outcomes happen, we just become correlated with one particular branch. The implications for the existence of the future are profound. In the Many Worlds interpretation, your future absolutely exists, but it's not singular. You don't have one future self. You have countless future selves living out every conceivable variation of your life. The version of you that chose differently, spoke differently, lived differently, they're all out there in parallel branches of reality, each believing they're the only real version, each living out their own story of choices and consequences. This view transforms how we might think about regret and possibility. Every path not taken is taken somewhere in the quantum multiverse. That career you always wondered about, that person you should have asked out, that trip you never took, they're all real somewhere. The Many Worlds interpretation doesn't eliminate the significance of choice. It multiplies it infinitely. Every decision branches reality, creating new worlds, new futures, new versions of yourself exploring different possibilities. But this raises its own puzzles. If every possible future exists, what makes your particular branch special? Why should you care about making good choices if every possible choice is being made by some version of you? Some philosophers argue that this reduces morality to meaninglessness. If you're charitable in this world but cruel in another, if you work hard here but lazy there, do your choices really matter? Others suggest that the personal significance of choice remains intact even in a Many Worlds universe. You might not be the only version of yourself, but you're the only version you'll ever be. Your choices determine which branch of reality you experience, which collection of memories and consequences you'll carry forward. The other versions of you aren't you in any meaningful sense. They're more like distant relatives, sharing your origin but living entirely separate lives. The Many Worlds interpretation also offers a unique perspective on death and mortality. If every possible future exists, then there are branches of reality where you live longer, perhaps much longer than in others. Some interpretations even suggest a form of quantum immortality, where your consciousness might always find itself in branches where survival is possible. Though this remains highly speculative and controversial, even among Many Worlds proponents. From a practical standpoint, Many Worlds doesn't change how you should live your life. You still experience one reality, make one set of choices, live with one set of consequences. The existence of parallel versions doesn't diminish the reality of your particular experience. If anything, it might enhance the significance of each moment, knowing that this particular combination of events, this specific path through possibility space, is unique in the multiverse. The many worlds interpretation preserves both the reality of the future and the genuineness of choice by making room for all possibilities. It's a generous universe, one that doesn't force reality to choose between alternatives, but allows every alternative to flourish in its own branch of existence. Whether this is comforting or overwhelming probably depends on your temperament and your need for uniqueness in an infinite cosmos. Some philosophers and physicists, uncomfortable with both the rigid fatalism of a completely predetermined block universe and the infinite proliferation of realities in many worlds theory, propose a middle path called the growing block theory. This elegant compromise attempts to preserve our intuitive sense that the future is fundamentally different from the past, while acknowledging the insights of relativity about the nature of space and time. In this view, the past and present are real and exist in a block-like structure, solid and immutable, carved forever into the architecture of space-time, but the future remains genuinely open, unreal, until it crystallizes into present reality and then hardens into the fixed past. Imagine the block universe as a growing crystal, expanding moment by moment as new reality forms at its leading edge. The past is crystallized, permanent, unchanging, its events locked forever into the structure of space-time like fossils preserved in stone. Every word you spoke yesterday, every choice you made last week, every moment of your childhood, they're all there in the crystal, solid and enduring, as real as the chair you're sitting in or the breath you're breathing right now. But the future remains liquid potential, quantum possibility space that hasn't yet undergone the mysterious transformation from mere possibility into concrete actuality. The present, in this view, is special in a way that pure eternalism doesn't allow. It's the growing edge of reality, the place where the possible becomes actual, where the quantum uncertainty of tomorrow crystallizes into the classical certainty of yesterday. This growing surface moves through space-time like a cosmic wave, constantly adding new slices of reality to the existing block, transforming potential into permanence with each passing moment. This theory preserves something important about our temporal experience that the block universe seems to threaten: the sense that the future is genuinely open to our influence. When you make plans for tomorrow, you're not just discovering a predetermined future, you're participating in the creation of new reality. Your choices, at the growing edge of the block, help determine what kind of future gets added to the permanent structure of space-time. You're not just a passenger riding through existing reality, you're a co-creator helping to build it. The growing block theory also makes sense of our asymmetric relationship with past and future. We remember the past, but not the future, because the past has the solid reality that allows for stable information storage, while the future lacks the definite structure necessary for memory. We can influence the future but not the past, because the future is still forming, still responsive to present causes, while the past has crystallized beyond the reach of change. But the growing block faces significant challenges from relativity theory. If simultaneity is relative, if different observers disagree about what events are happening now, then where exactly is the growing edge of the block? Alice on Earth and Bob in his speeding spaceship would place the boundary between real past and unreal future in completely different locations. Whose perspective determines what has crystallized into existence and what remains potential? Some growing block theorists suggest there might be a preferred reference frame, a cosmic perspective that determines the objective boundary between real and unreal. Perhaps the expanding universe itself provides this frame, with the growth of space determining the growth of temporal reality. Others propose that the growing edge isn't a sharp boundary, but a fuzzy transition zone where reality gradually solidifies from quantum potential into classical actuality. The growing block also faces questions about the mechanism of growth. What causes new reality to come into existence? What transforms possibility into actuality? Some theories connect this to quantum measurement, suggesting that the collapse of quantum superpositions is what adds new slices to the block. Others link it to thermodynamic processes, proposing that the increase of entropy drives the crystallization of new reality. Still others suggest that consciousness itself might play a role, that the act of observation or experience somehow catalyzes the transformation of potential into actual. These mechanisms remain speculative, but they point toward an intriguing possibility that the growth of reality might not be automatic or uniform. Perhaps some futures crystallize more readily than others. Perhaps highly probable quantum outcomes solidify faster than unlikely ones. Perhaps conscious observation accelerates the transition from possibility to reality, making the future more real around centers of awareness and observation. The growing block theory also offers a unique perspective on time travel paradoxes. If the past is real and fixed while the future remains open, then traveling to the past might be impossible, not because of logical contradictions, but because there's no mechanism to access the crystallized portions of the block from the growing edge. The past is real but sealed off, like exhibits in a cosmic museum that can be observed but not revisited. Future time travel, however, might be more problematic in a growing block universe. If the future doesn't exist yet, there's nowhere to travel to. You can't visit next Tuesday, if next Tuesday is still just potential waiting to crystallize. This could explain why time travel stories typically involve going backward rather than forward. Perhaps the universe's structure allows access to the past, but not to the non-existent future. From a personal perspective, the growing block theory might offer the best of both worlds. It preserves the meaningfulness of choice and the openness of tomorrow while acknowledging the permanent reality of memory and history. Your past experiences are forever real, but your future remains yours to shape. You're not trapped in a predetermined story, nor are you floating in a completely formless sea of possibility. Instead, you're standing at the edge of reality itself, participating in the ongoing creation of existence, helping to determine what becomes permanently real as the universe continues its magnificent growth through time. Another approach to understanding future existence focuses on information and causality rather than metaphysics, offering a perspective that sidesteps some of the more esoteric debates about block universes and quantum branching, while still grappling seriously with the question of whether tomorrow is already real. From this perspective, the future exists in a limited but meaningful sense as the inevitable consequence of present information combined with the fundamental laws of physics that govern how that information evolves through time. Consider a planet orbiting a star in the vast emptiness of space, following the elegant dance of gravity that has choreographed celestial motion for billions of years. Given the planet's current position and velocity, along with our understanding of gravitational forces and orbital mechanics, you can calculate exactly where that planet will be in 1,000 years, 10,000 years, even 1,000,000 years into the future. The mathematics are precise, the predictions reliable, the future trajectory as certain as any scientific knowledge we possess. In what sense does that future position exist? It exists as information encoded in the present state of the planetary system, waiting to unfold according to the deterministic laws that govern motion through space. This informational view of future existence is different from saying the future physically exists in the way a distant planet physically exists. It's more like saying the future is mathematically implied by the present, embedded in current conditions like a seed contains the information for a tree, or like a complex equation, contains all of its solutions waiting to be calculated. The future orbital position doesn't sit somewhere in space waiting for the planet to arrive. Rather, it emerges inevitably from the present state of the system as natural law transforms current reality into subsequent reality. But this deterministic picture becomes more complex when we zoom in from planetary orbits to the quantum realm where uncertainty reigns supreme. Even in systems that appear completely predictable at large scales, quantum fluctuations introduce subtle randomness that can compound over time into major changes. The butterfly effect, that poetic notion that a butterfly's wing flap in Brazil might trigger a tornado in Texas, reflects the mathematical reality that small uncertainties can grow exponentially in complex systems, making long-term prediction impossible even when the underlying laws are completely deterministic. This sensitivity to initial conditions means that the informational future exists only in a probabilistic sense. We can calculate likely outcomes, probable scenarios, statistical distributions of possible futures, but the exact details remain genuinely uncertain. The planet's future orbit can be predicted with confidence, but the exact position of every atom in that planet remains quantum mechanically uncertain. The future exists as information, but it's fuzzy information, probabilistic rather than definite. Weather systems provide a perfect example of this informational view of future existence. Meteorologists can predict tomorrow's weather with reasonable accuracy because tomorrow's atmospheric patterns are largely determined by today's temperature distributions, pressure gradients, and moisture content. Next week's weather exists as information in today's atmospheric state, though that information becomes increasingly uncertain as we look further ahead. The future storm exists informationally before it exists physically, embedded in current conditions like a photograph developing in chemical solution. But even deterministic systems can surprise us, because they often contain more information than we can practically extract. The three-body problem in celestial mechanics, where three massive objects orbit each other under mutual gravitational attraction, has no general analytical solution despite being governed by perfectly deterministic laws. The future exists in the system's current state, but accessing that future information requires computational resources that grow exponentially with time. The future is there, informationally speaking, but it remains practically unknowable beyond certain horizons. This informational perspective suggests that asking whether the future exists might be asking the wrong question. Instead, we might ask, what kind of information about the future is contained in present reality? How much of tomorrow is already determined by today's conditions? How far into the future can we peer using the telescope of natural law and mathematical prediction? The answers vary dramatically depending on the system we're examining and the level of detail we're interested in. For simple systems governed by well-understood forces, the informational future might extend very far indeed. The motion of planets, the decay rates of radioactive samples, the expansion of the universe itself, these follow patterns so reliable that we can make confident predictions spanning millions or billions of years. For complex systems involving weather, ecosystems, human behavior, or quantum mechanics, the informational future might extend only hours, days, or years before uncertainty overwhelms predictability. This raises intriguing questions about the relationship between knowledge and existence. If we could somehow calculate the complete future evolution of every quantum system in the universe, would that future then exist in a stronger sense than it does now? Is there a difference between a future that's determined but unknowable, and one that's determined and completely calculable? Perhaps existence comes in degrees, with more predictable, more informationally accessible futures having stronger claims to reality than highly uncertain or chaotic ones. The informational view also connects to questions about simulation and computation. If the future exists as information embedded in present conditions, then sufficiently powerful computers might be able to simulate future evolution, creating digital futures that mirror the informational content of physical reality. In some sense, running a perfect simulation of tomorrow might be equivalent to making tomorrow exist in computational form, raising questions about the relationship between information, simulation, and reality itself. This perspective offers a middle ground between the extremes of rigid predestination and complete openness. The future exists informationally, embedded in present reality like music encoded on a vinyl record, but accessing that future requires the gradual process of temporal evolution, like playing the record to hear the music. Tomorrow is real in the sense that it's determined by today, but it's not physically real in the sense of being directly accessible or observable. It exists as potential waiting to be actualized, as information waiting to be decoded by the passage of time itself. The direction of time, what scientists call time's arrow, might offer crucial clues about the existence and nature of the future. Because if time truly has a preferred direction built into the fabric of reality itself, then the past and future might indeed have fundamentally different relationships to existence. This arrow of time emerges most clearly from thermodynamics, that branch of physics concerned with heat, energy, and the inexorable tendency of organized systems to become disorganized, of hot coffee to cool down, of tidy rooms to become cluttered, of complex structures to decay into simpler ones, unless energy is continuously expended to maintain their organization. The second law of thermodynamics tells us that in any isolated system, entropy, a measure of disorder or randomness, always increases over time. This isn't just a statistical tendency or a rule of thumb. It's one of the most fundamental principles governing the behavior of matter and energy in our universe. And this one-way increase in entropy gives time its arrow, its sense of direction, its asymmetry between past and future that makes forward and backward genuinely different rather than merely arbitrary labels we attach to temporal directions. Think of it this way. Imagine a glass shattering on the floor, transforming from an organized low-entropy state into a scattered, high-entropy collection of fragments. That transformation happens spontaneously, naturally, inevitably given enough time and the random motions of thermal energy. But the reverse transformation, fragments spontaneously leaping back together into a perfect glass, never happens. Not because it violates the fundamental laws of physics, which are actually symmetric with respect to time, but because it's astronomically improbable. The statistical weight of all possible configurations favors disorder so overwhelmingly that ordered states are vanishingly rare. This thermodynamic asymmetry suggests that the past and future have fundamentally different characteristics. The past is low entropy, organized, crystallized by the irreversible increase of disorder that has already occurred. It's like a photograph that's been developed, fixed in chemical solution, no longer changeable. The future, by contrast, is high entropy, disorganized, still plastic and changeable because the full weight of thermodynamic evolution hasn't yet pressed it into final form. If time's arrow is real rather than illusory, if the direction from past to future reflects something objective about the structure of reality rather than merely the limitations of human perception, then it might indicate that the past and future have different ontological statuses. The past exists as fixed information, patterns carved in stone by entropy's irreversible chisel. The future remains fluid possibility, not yet hardened into existence by the irreversible flow of thermodynamic time. This connects to questions about memory and causality that go to the heart of temporal experience. We remember the past, but not the future, and this asymmetry might reflect the thermodynamic arrow rather than mere biological accident. Memories require physical traces, patterns in neural networks that persist through time. These traces can only form through irreversible processes that increase entropy. When you remember your childhood birthday party, you're accessing information that was burned into your brain's structure through thermodynamically irreversible processes. The future can't be remembered because it hasn't yet undergone the irreversible changes necessary to create stable information patterns. Similarly, we can influence the future but not the past, because influence requires the ability to create new patterns, new information, new organization, and these can only be imposed on systems that haven't yet reached thermodynamic equilibrium. The past has already undergone its entropic evolution. Its patterns are set. The future remains thermodynamically active, still evolving, still responsive to new inputs of energy and organization. This thermodynamic view of time's arrow suggests that the growing block theory might be more than philosophical speculation. Perhaps the boundary between real past and potential future isn't arbitrary, but reflects the objective progress of entropy through the universe. The growing edge of the block might correspond to the thermodynamic present, the boundary between systems that have undergone irreversible evolution and those that remain open to change. But this raises puzzles about the cosmic scale of entropy and time. The universe as a whole appears to be evolving from a low-entropy initial state toward a high-entropy final equilibrium. Heat death, where all temperature differences have evened out and no further work can be extracted from the cosmic energy budget. If this evolution is deterministic, governed by the same thermodynamic laws that make coffee cool and ice melt, then is the cosmic future already determined by the universe's initial conditions? Does the arrow of time point toward a specific, inevitable destination encoded in the Big Bang's initial low-entropy state? This connects to deeper questions about the origin of time's arrow itself. Why was the early universe in such a remarkably organized, low-entropy state to begin with? The cosmic microwave background shows us that the primordial universe was incredibly smooth and uniform, with only tiny fluctuations that would later grow into galaxies and stars through gravitational collapse. But why that initial organization rather than the high-entropy chaos we might expect from random chance? Some cosmologists suggest that the arrow of time, and perhaps the existence of time itself, might be connected to the universe's expansion. As space grows, it creates new room for entropy to increase, new possibilities for organization to arise, and then decay. The expansion might be what drives the thermodynamic arrow, providing the cosmic stage on which entropy can perform its one-way dance from order to disorder. Others propose that our observable universe might be just one region of a larger multiverse, where different regions have different thermodynamic arrows, different directions of increasing entropy. We find ourselves in a region where entropy increases toward our future, simply because that's the only kind of region where conscious observers like us could evolve to ask questions about time's direction. These cosmological perspectives suggest that the arrow of time might be more fundamental than our everyday experience suggests, woven into the structure of reality at the deepest level, determining not just whether we remember the past or anticipate the future, but whether the past and future have genuinely different relationships to existence itself. Our conscious experience of time might hold keys to understanding future existence, because consciousness doesn't just passively observe the flow of temporal events, but actively participates in shaping our understanding of what past, present, and future mean. We remember the past, but not the future. We can influence what we anticipate as tomorrow, but not what we recall as yesterday. And this fundamental asymmetry in consciousness mirrors time's arrow, while potentially revealing something deep about the nature of temporal existence itself. The act of remembering is remarkably different from the act of anticipating, not just psychologically, but in terms of the underlying neural mechanisms involved. When you recall your childhood home, your brain accesses stored information, patterns of neural connections that were formed through actual experience, and preserved through the biochemical processes of memory consolidation. These memories have a certain solidity, a resistance to change, that reflects their basis in physical traces left by past events. You can't simply decide to remember something differently, though memories do fade and distort over time through the natural decay of their neural substrates. But when you imagine your future home, when you picture where you might be living in 5 years, your brain is doing something entirely different. It's constructing possibilities, combining elements from past experience with projected desires and fears, creating mental scenarios that have no necessary correspondence to any actual future reality. These future projections are fluid, changeable, responsive to your current mood and circumstances in ways that memories generally aren't. You can decide to imagine a different future, but you can't decide to remember a different past. This asymmetry might reflect something fundamental about the relationship between consciousness and time, rather than merely the biological limitations of neural storage systems. Some researchers suggest that consciousness doesn't just experience time, but participates in creating the distinction between fixed past and open future. Our ability to make choices, to collapse quantum possibilities through observation and decision, to remember selectively, and project imaginatively, these might be the mechanisms by which fluid possibility crystallizes into concrete reality. From this perspective, the future exists as potential until consciousness, through choice and observation, transforms it into the definite past. We don't just experience time, we're participants in its creation, helping to weave the fabric of temporal reality through our decisions and awareness. Every choice you make, every observation you conduct, Every moment of conscious experience might be contributing to the ongoing crystallization of possibility into actuality. This view connects consciousness to the measurement problem in quantum mechanics, that persistent puzzle about how and why quantum superpositions collapse into definite outcomes. If consciousness plays a role in quantum measurement, then conscious beings might be actively involved in determining which possibilities become real. Your future doesn't just exist. Your consciousness helps determine which future exists by participating in the quantum processes that select specific outcomes from the vast space of possibility. But this raises questions about the scope and limits of conscious influence. Can your consciousness really affect quantum events in your brain? Do your choices genuinely alter the future, or do they simply determine which branch of an already existing multiverse you experience? The relationship between mind and quantum mechanics remains one of the most contentious areas in both physics and philosophy of mind, with interpretations ranging from consciousness being completely irrelevant to quantum processes, to consciousness being essential for the collapse of quantum states. Consider the temporal structure of decision-making itself. When you deliberate about a choice, you're considering various possible futures, weighing their likely consequences, imagining how different decisions might unfold into different life trajectories. This process feels creative, generative, like you're actively constructing the future through conscious reflection. But is this feeling accurate, or are you simply discovering a choice that was always going to be made, a future that was always going to unfold? The experience of choice might offer clues about the nature of temporal existence. When you genuinely deliberate between alternatives, multiple futures feel possible, real enough to influence your emotional state and decision-making process. You can feel anxious about bad futures and excited about good ones, even though only one of them will actually come to pass. This suggests that consciousness relates to multiple futures simultaneously, as if your awareness can access the probability space of tomorrow, even before tomorrow crystallizes into definite reality. Some philosophers argue that this multiplicity of experience possibilities points toward the reality of alternative futures. If you can genuinely feel the weight of different choices, if various possible tomorrows can exert emotional and psychological influence on your present experience, then perhaps those futures have some form of existence even before they become actual. Your consciousness might be sensitive to the quantum probability currents that flow between present and future, detecting the likelihood and significance of various outcomes before they crystallize into concrete events. The relationship between consciousness and temporal existence becomes even more puzzling when we consider altered states of awareness. During deep meditation, intense creativity, or certain kinds of spiritual experience, people often report a dissolution of temporal boundaries, a sense of existing outside normal time, or an awareness that encompasses past, present, and future simultaneously. These experiences might be illusions created by changes in brain chemistry and neural activity, but they could also represent genuine glimpses into the deeper structure of temporal reality. Moments when consciousness temporarily escapes its usual confinement to a narrow slice of the present moment. Let's zoom out to cosmic scales and consider whether the question of future existence even matters when viewed from the perspective of the universe as a whole, because on the largest scales of space and time, the distinction between past, present, and future might dissolve into something altogether different. The cosmos operates on time scales so vast that human intuitions about temporal flow become almost meaningless, like trying to perceive the motion of continents or the dance of galaxies with senses evolved to track the movement of prey across ancient savannas. Consider the cosmic microwave background, that faint afterglow of the Big Bang that still bathes the entire universe in ancient light, carrying information about cosmic conditions from when the universe was only 380. 0 years old, a mere infant by cosmic standards. This radiation encodes details about the early universe's temperature, density, and composition with remarkable precision, creating a baby picture of the cosmos that we can still observe today, 13.8 billion years later. But this ancient light doesn't just tell us about the past. It also constrains the future through the mathematical relationships between early conditions and subsequent evolution. The tiny fluctuations visible in the cosmic microwave background, variations in temperature of only a few millionths of a degree, were the seeds from which all cosmic structure eventually grew. These quantum fluctuations, stretched to cosmic size by the rapid expansion of early space, determined where galaxies would eventually form, where dark matter would clump together, where the vast cosmic web of filaments and voids would take shape. In a very real sense, the future structure of the universe was encoded in these primordial fluctuations, written into the fabric of space-time when the cosmos was younger than a human heartbeat. From this cosmic perspective, the future might exist as the inevitable unfolding of initial conditions set nearly 14 billion years ago. The formation of galaxies, the birth and death of stars, the synthesis of heavy elements in stellar cores, the eventual expansion and cooling of space itself, these cosmic events might all be encoded in the early universe's quantum fluctuations, making the cosmic future as real and determined as its ancient past. The universe might be like a vast clockwork mechanism wound up at the moment of the Big Bang, its future evolution already implicit in its initial configuration. But even on cosmic scales, quantum mechanics introduces elements of genuine uncertainty that complicate this deterministic picture. While the large-scale structure of the universe follows predictable patterns of gravitational collapse and expansion, the exact timing of stellar explosions, the precise paths of galaxy collisions, the specific moment when the last star will exhaust its fuel and die, these events remain influenced by quantum processes that introduce irreducible randomness into cosmic evolution. The death of stars provides a perfect example of this interplay between cosmic determinism and quantum uncertainty. We can predict with confidence that our sun will exhaust its hydrogen fuel in approximately 5 billion years, expanding into a red giant and eventually ejecting its outer layers to form a planetary nebula while its core collapses into a white dwarf. This stellar future is written in the physics of nuclear fusion and stellar structure as clearly as any cosmic prophecy. But the exact moment when the sun's core will reach the critical temperature for helium fusion, the precise dynamics of its red giant phase, the specific shape of its eventual planetary nebula, these details remain quantum mechanically uncertain. The far future of the universe presents an even stranger case. Current cosmological models suggest that the universe will continue expanding and cooling for trillions of years, eventually reaching a state of maximum entropy where all energy has been evenly distributed and no further work can be extracted from cosmic processes. This heat death represents the ultimate arrow of time, the final destination toward which thermodynamic evolution points. But reaching this state would require time periods so vast that they dwarf the current age of the universe by factors of billions or trillions. During these unimaginable future eons, quantum mechanics might play an increasingly important role. In the far future, when normal matter has decayed and only the most stable particles remain, quantum fluctuations could become the dominant source of cosmic change. Virtual particles popping in and out of existence, quantum tunneling events that violate classical energy conservation for brief moments, the spontaneous formation of structures through random quantum processes. These might be the only sources of novelty in a universe that has otherwise reached thermodynamic equilibrium. Some cosmologists even speculate about quantum resurrection, the possibility that random fluctuations in the far future could spontaneously recreate complex structures, including brains, planets, even entire civilizations. The timescales involved are so long that they make the current age of the universe seem like the blink of an eye. But if quantum mechanics is correct about the fundamental randomness of vacuum fluctuations, then every possible configuration of matter would eventually occur by pure chance. From this cosmic perspective, the question of whether the future exists becomes almost poetic rather than scientific. On time scales of billions and trillions of years, individual human choices and quantum uncertainties average out into grand statistical patterns. The cosmic future might be simultaneously predetermined and random, inevitable in its broad outlines but uncertain in its details, like a river that must eventually reach the sea, but whose exact path remains influenced by local conditions and chance encounters with obstacles. This cosmic view might suggest that the existence of the future is scale-dependent. On human timescales, quantum uncertainty and conscious choice might keep the future genuinely open. On cosmic timescales, thermodynamic evolution and gravitational dynamics might make the future effectively predetermined. The question of future existence might not have a single answer, but rather different answers, depending on which temporal perspective we adopt, which level of detail we're interested in, and which physical processes we're examining. If the future already exists, whether as a fixed block of space-time or as branching quantum possibilities, how should this knowledge change how we live our daily lives? Does it matter for our choices, our hopes, our fears, our sense of purpose and meaning? These aren't just abstract philosophical questions, but practical concerns that touch the very core of human experience, influencing how we approach everything from career decisions to relationships, from moral responsibilities to our deepest anxieties about mortality and meaning. Some find the block universe profoundly comforting, a source of peace that transforms their relationship with time and mortality. If your future already exists somewhere in the four-dimensional landscape of space-time, then in the most fundamental sense possible, you're eternal. Every moment of your life, past and future, has equal claim to reality. Your childhood wonder at discovering snow for the first time, your current thoughts as you listen to these words, your eventual wisdom gained through decades of experience, they're all equally real, different chapters in the enduring story of your existence through space-time. This perspective can ease the anxiety that comes with time's apparent passage. We often feel pressure to make every moment count, to hold on to experiences before they slip away, to somehow capture and preserve the fleeting beauty of temporary things. But if the block universe is true, nothing is truly temporary. Every sunset you've watched exists forever in its slice of space-time. Every conversation with a loved one, every moment of unexpected joy, every quiet evening like this one, they don't fade into non-existence when they pass. They remain permanently real, forever part of the structure of reality, as enduring as the laws of physics themselves. Death, from this perspective, becomes not an ending but a boundary, like the edge of a photograph or the final page of a book. The photograph doesn't cease to exist when you stop looking at it. The story doesn't become unreal when you finish reading it. In the same way, your life doesn't lose its reality when your consciousness can no longer access future slices of your world line. Every moment you've lived, every experience you've had, remains eternally real in the block, a permanent contribution to the universe's store of actual events. Others find this view deeply troubling, even claustrophobic. If your entire life already exists, if every mistake and triumph is already laid out in the block-like scenes in a movie that's already been filmed, does that leave room for growth, for change, for the feeling that tomorrow could be genuinely different from today? The block universe can seem to reduce human existence to a kind of cosmic determinism where free will becomes meaningless and effort pointless. But perhaps this worry stems from thinking about the block universe in overly fatalistic terms. The block tells us that all moments exist, but it doesn't necessarily tell us why they exist the way they do, or prevent them from being the result of genuine choice, effort, and the complex interplay of consciousness with physical reality. Your future choices might be real, existing somewhere ahead of you in space-time, but they're still your choices, made by your future self through processes of deliberation and decision that are as real as any other aspect of your extended existence through time. Consider the analogy of a novel that's already been written. The story exists completely, every chapter and page already determined by the author's choices. But within the story, the characters still make genuine decisions, still face real dilemmas, still grow and change through their experiences. The pre-existence of the narrative doesn't make the characters' choices less meaningful within the context of their story. In the same way, the pre-existence of your future in the block doesn't necessarily make your choices less real or meaningful within the context of your existence through space-time. The block universe might also change how we think about regret and missed opportunities. If every path not taken exists somewhere in the quantum multiverse, if every alternative choice is being lived out by some version of you in parallel realities, then perhaps regret loses some of its sting. The road not taken is taken somewhere. The words you didn't say are spoken in other timelines. The risks you didn't take are being taken by other versions of yourself who made different choices at crucial moments. This doesn't eliminate the significance of your particular path through reality, but it might ease the weight of wondering what might have been. Your choices still matter enormously for determining which branch of existence you experience, which collection of memories and consequences you'll carry forward, which version of the multiverse becomes your home. But the anxiety about missed possibilities might fade when you realize that no possibility is ever truly missed, just experienced by different versions of yourself in different branches of the infinite tree of reality. Some people find this multiplication of selves disturbing rather than comforting. If there are countless versions of you making every possible choice, what makes your particular version special? Why should you strive to be good if other versions of you are being evil? Why work hard if other versions are being lazy? But perhaps this misses the point. You might not be the only version of yourself, but you're the only version you'll ever be. Your choices determine which branch of reality you experience, which memories you'll form, which consequences you'll live with. The practical implications might be surprisingly minimal. Even if the future exists in some form, you still experience uncertainty about it. You still need to make choices based on incomplete information. You still benefit from planning, hoping, striving, and caring about outcomes. The existence of the future doesn't eliminate the lived experience of moving toward it, of discovering what was always there through the process of temporal becoming. The question of future existence connects to some delightfully mind-bending paradoxes that challenge our understanding of causality, information, and the very possibility of logical consistency in a universe where tomorrow might already be as real as yesterday. If the future already exists, laid out in the permanent structure of space-time, then information could potentially flow backward from future to past, creating causal loops that seem to violate our deepest intuitions about how cause and effect should work. Consider the bootstrap paradox, also known as a causal loop or ontological paradox, one of the most elegant puzzles in the philosophy of time travel. Imagine you receive a beautiful poem in the mail, unsigned, with no return address, but somehow you know it's from your future self. You're moved by its beauty. Memorize every line. Carry it with you through the years as a source of comfort and inspiration. Decades later, as an elderly person reflecting on your life, you remember that poem and decide to write it down and mail it to your younger self, completing the loop. But here's the puzzle. Where did the poem originally come from? The poem seems to bootstrap itself into existence, appearing from nowhere, with no ultimate origin. Your young self didn't create it. You received it from the future. Your old self didn't create it either. You were just copying something you remembered from your youth. The information seems to exist in a closed loop caused by itself, with no external source or creator. It's as if the poem always existed in the temporal loop, neither created nor destroyed, just circulating endlessly between future and past. These bootstrap scenarios become theoretically possible if the future exists as concretely as the past. Information could loop back on itself, creating closed causal chains where effects precede their causes or where causes are their own effects. A song could inspire its own composition. A scientific discovery could provide the knowledge necessary for its own invention. A decision could be made because of consequences that only occur because the decision was made. While these scenarios make logically consistent stories, they violate our normal understanding of how information and causality work. We expect causes to precede effects, origins to come before consequences, inventors to exist before their inventions. Bootstrap paradoxes suggest a universe where the arrow of causality might be more flexible than our everyday experience implies, where the flow of information through time might be more complex than the simple past-to-future progression we typically assume. Some solutions to bootstrap paradoxes invoke the many worlds interpretation. Perhaps the poem doesn't bootstrap itself in a single timeline, but emerges from the intersection of multiple quantum branches. Your young self receives the poem from a future self in one branch, but that future self originally created the poem based on inspiration from a different branch, where the poem had a conventional origin. The apparent bootstrap dissolves when viewed from the perspective of the full quantum multiverse, though it creates its own puzzles about the coordination between parallel realities. Other approaches suggest that bootstrap paradoxes might be self-consistently impossible. The Novikov self-consistency principle, named after physicist Igor Novikov, proposes that the universe's structure prevents logical contradictions even when time loops are possible. If you tried to create a bootstrap paradox, something would go wrong. The poem would be lost in the mail, your memory would fail, or circumstances would conspire to prevent the causal loop from closing. The universe would protect itself from logical inconsistency through a kind of cosmic immune system. But perhaps the most unsettling possibility is that bootstrap paradoxes reveal something fundamental about the nature of information and reality. Maybe information doesn't always need an external source. Maybe some patterns, some ideas, some structures are so fundamental to the fabric of reality that they can exist without being created, without having origins in the conventional sense. Just as mathematical truths like the Pythagorean theorem seem to exist independently of any particular mathematician who discovers them, maybe certain informational patterns exist independently of any particular moment or cause that brings them into being. This connects to deeper questions about the relationship between information, consciousness, and temporal existence. If consciousness is fundamentally about processing information, about extracting patterns and meaning from sensory input and memory, then bootstrap paradoxes might reveal something about how consciousness relates to the informational structure of space-time itself. Perhaps certain ideas or insights exist timelessly in the mathematical structure of reality, accessible to consciousness at multiple points along its journey through space-time. The bootstrap paradox also illustrates the strange relationship between knowledge and existence in a block universe. If all moments already exist, then all discoveries have already been made, all insights already achieved, all creative works already created. But they exist distributed through time, waiting for conscious minds to encounter them at the appropriate moments in their world lines. Discovery becomes not creation but revelation, the uncovering of truths that were always there in the permanent structure of space-time. These paradoxes remind us that if the future exists, it exists in ways that stretch our normal categories of thought. Causality, creation, and novelty might all need to be reconsidered in light of a reality where tomorrow is as real as yesterday, where information can flow in loops, and where the distinction between discovery and creation becomes blurred in the strange landscape of eternal space-time. Can science actually resolve whether the future exists, or are we doomed to perpetual philosophical speculation about temporal ontology? While the question touches on some of the deepest mysteries in physics and philosophy, several experimental approaches might offer clues, though the answers they provide are likely to be subtle, indirect, and open to multiple interpretations, rather than definitive pronouncements about the nature of tomorrow. Tests of Bell's theorem in quantum mechanics probe the fundamental nature of reality and causality in ways that connect directly to questions about temporal existence. Bell's inequality, derived in 1964, provides a mathematical test that can distinguish between local realistic theories, where particles have definite properties independent of observation, and quantum mechanical predictions that violate our classical intuitions about how reality should behave. Experiments consistently violate Bell's inequality, suggesting that either locality or realism, or both, must be abandoned in our understanding of quantum systems. But Bell tests have temporal implications that extend beyond the usual discussions of quantum entanglement. If quantum mechanics is complete and accurate in its predictions, then the future state of quantum systems cannot be determined by present information alone. This places limits on how much of the future can be considered real in the deterministic sense. The future might exist as probability distributions and quantum amplitudes, but not as definite, concrete events waiting to be discovered. This quantum indeterminacy suggests that the block universe, if it exists, must be probabilistic rather than deterministic, filled with branching possibilities rather than fixed certainties. Experiments in quantum delayed choice offer another window into the relationship between present observations and future reality. In these experiments, the decision about how to measure a quantum system is made after the system has already interacted with the measuring apparatus, but before the measurement is completed. The results suggest that future measurement choices can influence the past behavior of quantum systems, creating apparent causal loops where tomorrow's decisions affect yesterday's events. These delayed choice experiments don't prove that the future exists, but they do suggest that the relationship between past, present, and future might be more complex than our everyday experience suggests. If future measurements can retroactively determine past quantum states, then the boundary between what has happened and what will happen becomes blurred in ways that support neither pure presentism nor simple eternalism, but something more nuanced and strange. Searches for time travel or closed time-like curves represent more direct attempts to test whether the future is physically accessible from the present. While no confirmed examples of time travel have been discovered, theoretical physics allows for several mechanisms that could, under extreme conditions, permit travel into the past. These include rotating black holes, cosmic strings, and hypothetical wormholes that connect distant regions of space-time. If any of these time travel mechanisms actually exist and function, they would provide strong evidence that the future has some form of objective reality. You can't travel to a destination that doesn't exist. But the absence of time travelers from the future, despite decades of searching and the obvious appeal of temporal tourism, might suggest either that time travel is impossible or that the future doesn't exist in a form that permits backward access. Studies of consciousness and free will might illuminate whether our sense of temporal becoming reflects genuine metaphysical becoming or merely psychological experience. Neuroscience experiments that monitor brain activity during decision-making have found that some choices can be predicted from neural activity several seconds before people report being aware of their decisions. This suggests that what we experience as free choice might be the conscious recognition of decisions already made by unconscious brain processes. If consciousness is simply becoming aware of choices that have already been determined by prior neural activity, then perhaps our sense of creating the future is similar. We might not be generating new reality through conscious choice, but rather discovering a future that was already implicit in the complex dynamics of our brains and the physical systems we interact with. This wouldn't eliminate the significance of choice, but it would relocate it from the moment of conscious decision to the earlier neural processes that generate those decisions. Cosmological observations offer another avenue for investigating temporal existence. The cosmic microwave background radiation carries information about the early universe that constrains possible futures through the mathematical relationships between initial conditions and subsequent evolution. If we could develop sufficiently sophisticated models of cosmic evolution, we might be able to determine how much of the universe's future is genuinely open and how much is already implicit in present conditions. Dark energy and the accelerating expansion of space present particular puzzles for understanding cosmic time. The discovery that the universe's expansion is speeding up rather than slowing down suggests that the cosmic future might be more open than previously thought, less determined by initial conditions, and more influenced by the mysterious properties of dark energy that remain poorly understood. But perhaps the most promising approach to testing future existence lies in developing better theories that unify quantum mechanics with general relativity. The problem of time in quantum gravity, where temporal variables disappear from the fundamental equations describing the universe as a whole, might hold keys to understanding whether time and temporal existence are fundamental features of reality or emergent properties that arise only at certain scales or under certain conditions. These scientific approaches won't provide simple yes or no answers to questions about future existence, but they might reveal the deeper structure of temporal reality in ways that inform our philosophical understanding. Science has a history of transforming seemingly pure philosophical questions into empirical puzzles that can be addressed through observation and experiment, and the nature of time might eventually join the ranks of mysteries that yield to scientific investigation. Ultimately, the question of future existence might be as much about meaning and purpose as it is about physics and metaphysics. How we answer it shapes how we understand responsibility, hope, mortality, and the significance of human choice in ways that ripple through every aspect of lived experience. The stakes of this seemingly abstract question turn out to be intensely personal, touching our deepest concerns about agency, meaning, and what it means to be conscious beings embedded in time. If the future already exists, are we explorers discovering a predetermined landscape, brave adventurers mapping territory that was always there? Or are we authors writing a story that somehow already exists, creating something that paradoxically preceded its own creation? The metaphors we choose reveal different ways of understanding the relationship between consciousness, choice, and temporal reality, each with its own implications for how we should live and what we should value. The explorer metaphor suggests a universe of fixed destiny where wisdom lies in acceptance, in learning to navigate skillfully through a landscape whose features have already been determined. In this view, the art of living becomes a matter of reading the terrain correctly, of understanding the constraints and possibilities inherent in your particular path through space-time, of finding peace with a journey whose destination was always known, even if the traveler remains ignorant of where the path leads. The author metaphor, by contrast, suggests active participation in creation even within the constraints of an already existing narrative. Writers work within the bounds of language, plot structure, and character development, but their choices within those constraints are genuine and meaningful. The story exists because of the author's decisions, not in spite of them. In the same way, your future might exist because of your choices rather than independently of them, shaped by your decisions, even if those decisions are themselves eternal features of the block universe. Perhaps the question itself reflects something fundamental about human nature that transcends its literal answer. We are temporal beings, creatures whose very identity is woven from threads of memory and anticipation, whose consciousness exists in the strange boundary zone between what was and what will be. Our sense of self depends on temporal continuity, on the feeling that the person who woke up this morning and the person who will wake up tomorrow are connected by more than just physical continuity, but by an ongoing stream of experience and choice. Whether the future exists might matter less than how we choose to live within time's mystery. The question forces us to confront fundamental assumptions about consciousness, choice, and meaning that we rarely examine directly. Do our choices matter because they create the future, or because they determine which future we experience? Is hope meaningful because it shapes what will happen, or because it shapes how we encounter what was always going to happen? The various answers to future existence also reflect different approaches to uncertainty and control. Those who find comfort in an already existing future might be seeking relief from the anxiety of responsibility, the burden of shaping outcomes they cannot fully predict or control. Those who insist the future must be open might be protecting their sense of agency, their belief that effort and choice make genuine differences in how reality unfolds. But perhaps both perspectives capture something true about temporal existence. The future might be both determined and open, both real and potential, both discoverable and creatable, depending on which aspect of time we're examining and which scale of description we're using. Just as light can be both wave and particle depending on how we observe it, time might be both flowing and static, both creative and predetermined, both meaningful and inevitable. The question of future existence also connects to how we understand death and mortality. If your entire life already exists in space-time, then death becomes a boundary rather than an ending, the final page of a story that continues to exist even after it's been read. But if the future genuinely doesn't exist until it becomes present, then death represents a genuine termination, the cessation of the ongoing creation of new experience and possibility. These different views of mortality might influence how we approach the limited time we have. Whether we understand ourselves as eternal beings discovering a permanent story, or as temporary patterns briefly flickering in the flow of cosmic time. Both perspectives can motivate care, love, and meaningful action, but they do so for different reasons and with different emotional textures. Perhaps the deepest insight from contemplating future existence is that the question reveals the strange and wonderful position of consciousness in the cosmos. We are beings capable of asking whether tomorrow exists, creatures who can contemplate our own temporal nature, wonder about the reality of what hasn't happened yet, and find meaning in questions that might have no final answers. That capacity for temporal reflection might be more remarkable than any particular answer we discover about the nature of time itself. And so, dear listener, we reach the end of our journey through tomorrow's mysteries. Though if the block universe is true, this ending already existed before we began, patiently waiting for our consciousness to discover it like a hidden treasure that was never really hidden, just temporarily outside our awareness. We've wandered through Einstein's revolutionary insights about the relativity of simultaneity, quantum uncertainty, and the many worlds interpretation, growing block theories and thermodynamic arrows, consciousness and causality, bootstrap paradoxes, and cosmic perspectives. Along the way, we've seen that the simple question, does the future already exist, opens into a vast landscape of possibility, each answer raising new questions about the nature of time, choice, and existence itself. What have we learned from this gentle expedition through temporal philosophy and physics? Perhaps that the future is neither simply real nor simply unreal, but something more subtle, more mysterious, more resistant to easy categorization than our everyday language can capture. Maybe it exists as potential encoded in present conditions, probability waves rippling through quantum fields, mathematical inevitabilities waiting to unfold according to natural law. Maybe it branches into countless parallel possibilities, all equally real, all playing out simultaneously in the infinite theater of the multiverse. Maybe it grows moment by moment from the quantum foam of possibility into the crystalline certainty of the past, with consciousness itself serving as gardener, cultivating specific outcomes from the endless garden of potential. Or perhaps the question reveals something deeper about the limitations of human language and thought when confronted with the true nature of temporal reality. We are creatures evolved to navigate the middle world of medium-sized objects, moving at moderate speeds, where cause clearly precedes effect, where the past feels fixed and the future feels open, where time flows like a river, carrying us from birth to death. Our concepts of existence, reality, and temporal flow are shaped by this evolutionary heritage, and they might simply be inadequate for grasping the true structure of space-time as revealed by modern physics. The universe might operate according to principles so alien to human intuition that our questions about future existence are like asking what color Wednesday tastes like, or whether the number 7 is taller than the concept of justice. Not meaningless questions, perhaps, but questions that reveal the mismatch between the categories our minds are equipped to use and the categories that reality actually employs in its deeper operations. As you prepare for sleep tonight, consider this mystery that has accompanied us through our exploration. Whether or not tomorrow already exists somewhere in the block of space-time, it waits for your consciousness to meet it, to shape it through your choices if choice is real, or to discover it through your experience if choice is illusory. The future may or may not be real, but your journey toward it certainly is, filled with the genuine uncertainty that makes each moment precious, regardless of whether that moment was always destined to arrive or is being created fresh from the quantum possibilities that surround us. Perhaps the deepest insight from our temporal voyage is that human consciousness occupies a unique and strange position in the cosmos. We are patterns of matter and energy complex enough to contemplate our own existence through time, to wonder about the reality of moments we haven't experienced yet, to find meaning in questions that might ultimately be unanswerable. That capacity for temporal reflection, for wondering about tomorrow while living in today, might be more remarkable than any particular answer we discover about the nature of future existence. The question of whether the future exists also connects to how we find meaning and purpose in lives that unfold moment by moment, choice by choice, breath by breath. If your future already exists, perhaps meaning lies in the quality of experience, as you discover what was always there, in the depth of awareness you bring to each moment of your predetermined journey. If the future remains genuinely open, perhaps meaning lies in the responsibility of creation, in the weight of choices that genuinely shape what will come to pass. But maybe meaning doesn't depend on resolving these metaphysical puzzles. Maybe it emerges from the lived experience of being conscious in time, regardless of whether that time flows or stands still, whether the future exists or remains purely potential. The love you feel, the beauty you perceive, the connections you make with other conscious beings, these might be meaningful not because they occur in flowing time or eternal space-time, but because they occur at all, because consciousness somehow emerged in this universe capable of experience, reflection, and wonder. So rest well, fellow traveler, through whatever time turns out to be, and know that whether tomorrow is already written in the cosmic script or is yet to be authored by the quantum pens of possibility, it will be yours to experience, to live, and to transform through the simple miracle of being conscious in whatever temporal reality we inhabit. The future may or may not exist, but your encounter with it, when it comes, will be real in the most immediate and undeniable sense possible. Sweet dreams, and may your tomorrows, whether they already exist in the eternal block of space-time or are yet to crystallize from the quantum foam of possibility, unfold with wonder, meaning, and the peculiar joy that comes from being awake in a universe mysterious enough to pose such beautiful questions about its own nature. Sleep well, knowing that whatever time is, whatever the future holds, you are part of the cosmic story, a conscious thread in the vast tapestry of existence. Whether that tapestry is being woven moment by moment, or has always existed complete in the timeless mathematics of eternity.